Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with the UV protective textiles. In the last session, we have discussed the environmental factors like wet and dry UPF, elevated humidity exposure, effect of stretching and effect of sweating. Now, try to see the durability and aging after long term exposure of UV ray on the performance of the textile. So, if we use the fabric for long time, what will be its performance on the UPF performance will be there. So, after long time we must go for laundering, repeated washing cycle is required. So, repeated washing cycles which induce the fiber swelling and polymer chain relaxation and potential additives which has been added on the fabric surface, different types of finishing, different type of coating that may get extracted. So, that is because due to the repeated washing cycle and repeated fiber swelling will be there and polymer chain relaxation will be there for during swelling. So, mechanical agitation may alter the fabric structure. So, fabric structure may get distorted particularly for loose fabric structure. So, which may change the porosity and also the UV transmission characteristics may change. So, if the fabric structure get distorted, particularly loose structure like satin, twill, sometime it get distorted. The UPF typically decreases 5 to 15% after 50 standard wash cycles. That is actually experimental, it has been observed, though some finishes improve with the initial laundering. So, due to this repeated laundering, the UPF value little bit decreases. Now, this is the laundering. Now, aging of fabrics versus UV resistance. So, if you long term environmental impact. So, if we keep the fabric, if we use the fabric in a particular environment for long time, what will be there? So, long term environmental exposure causes cumulative photochemical change damages. So, it due to the light. So, photochemical damages will be there in the polymer chain. Polymer chain may get damaged and sometime crystallinity may change. So, due to all this it will actually affect the UV protection performance. So, if the crystallinity changes or polymer chain length also it is changes. So, that is due to the photochemical damage. So, that will affect the UV resistance. So, natural weathering combines the UV radiation, thermal cycling and moisture, because natural weathering like UV radiation is there, thermal cycling, it may here temperature is changing, increasing or decreasing, or moisture, presence of moisture which accelerates the material's degradation. So, material, when material gets degraded, so this UV resistance characteristics will be affected. So, the accelerated weathering testing. So, for this type of aging, if we want to know the aging, so aging effect is for long term. So, we cannot predict, because after maybe after 1 year or after 2 years we can how it is very difficult to predict. So, accelerated weathering test is done using the xenon arc or UV fluorescent lamps we can use to predict the severity of the effect, and its service life can be predicted under controlled condition. So, we can use at different humidity condition, at different temperature and different artificial UV source, that will actually we can from that we can predict the surface life of the protective textiles. The chemical factors in UV protection performance, what are the different types of chemical factors are there? Now, different color colorant chemistry and UV blocking pigments are used. So, if we use different color, that will change the UV protection performance, and UV blocker pigments are also used. So, dye molecule structure actually greatly influence the UV absorption, like azo dye, anthraquinones and the different types of dyes are there, okay, with extended conjugation provide superior UV attenuation. So, the different types of dyes which will improve the UV protection, and also inorganic pigments like titanium dioxide or zinc oxide offer broad spectrum UV blocking. So, with a wide range of wavelength that we can be blocked by titanium dioxide or zinc oxide through combined absorption and scattering mechanism. So, it can absorb also, and at the same time it can get the wave that can get scattered, UV ray scattering. So, that is the color chemistry or pigments. Next is that optical brightener, an additive. So, if we can add to the textile material this type of chemicals, that will also enhance the ultraviolet protection purpose. One thing we have used earlier. So, one is the fiber chemistry that we can use, then the engineering of the yarn and fabric structure, and also color chemistry. Through color chemistry we can enhance the UV protection performance, and also some additive chemicals like optical brightening agent or additive that will add to the UV protection performance, like fluorescent whitening agent. If we use on the as a finishing agent, okay, as a coating that absorbs UV radiation and re-emits visible blue light, So, it will actually fluorescent light, it will emit the visible blue lights, and that will actually it absorbs the UV ray. After absorbing, then it will emit the visible blue light, which is actually paradoxically reducing the measured UPF despite of enhancing the aesthetic appearance. That is very important. It is the optical brightening agent, that is if we use it emits, it will enhance the aesthetic appearance. The fabric becomes very nicely looking, but at the same time it will absorb the UPF. So, this type of chemistry we can use, and it is being used widely by optical whitening agent adding. So, that will enhance the UV absorption. So, additive migration during the processing or use may cause non-uniform UV protection. So, if we add the additive, okay, and if it migrates from one place to another places. So, whatever additive we are using, if it remains in that place, then there will be uniform UV protection, but if it migrates during processing or use or during laundering, if the additive is migrated or removed, so then there will be non-uniform protection and performance will get deteriorated with the time. So, that additive migration we should see, we should be careful what type of additives we are using, how are they forming bond with the textile structure. So, that these issues we should take care. And another thing is that dye degradation and photo fading is also important for UV protection like. So, photochemical reaction breaks the chromophoric bonds there, causing color loss and reduce the UV absorption capacity. So, when the we dye the any cloth at a dark color, so that will absorb the UV that we have discussed, but during the photochemical reaction, if the dye fades and color value is lost, so then it will affect the UV absorption, it will reduce the UV absorption capacity. So, that oxidative photodegradation generates free radicals that catalyzes the polymer chain, that polymer chain length is reduced, and which compromising both aesthetic and protective performance. So, that is the oxidative photo degradation also take place, and antioxidant stabilizers are used and UV absorbers are that mitigate the photo fading in high performance textile. So, antioxidant stabilizers are used and UV absorbers are used for high active high performance textiles, where the sensitivity is very high, where the UV radiation is very high. In those cases, that antioxidant stabilizers are used. Now, with the textile, the textile materials gets affected with the UV ray. So, that complex degradation mechanism one must understand to keep the protective performance of textile intact. Now, UV degradation and photo degradation mechanism. So, for textile material, as these are polymeric material, so that the textile material gets affected, degraded by UV ray. So, photon absorbs, initiates complex radical chemistry within the polymer matrix. So, when UV photon is absorbed, so it will change the complex chemistry, and photo oxidation incorporates atmospheric oxygen into the polymer chain. So, that is important, forming carbonyl and hydroxyl groups that accelerate further degradation. So, fiber the polymer gets degraded quickly by UV ray, and once it gets degraded, then subsequently that its mechanical characteristics, comfort characteristics and UV protection, everything will get deteriorated. So, that we should use certain material which actually is protected, or the degradation is slow. This type of material we should use, and the soil, dust and heat interaction effects. You can see the particular combination increases the fabric's absorbance through the light scattering and may introduce photocatalytic species accelerating degradation, that will at soil or dust or heat interaction. So, and it will combine with the UV exposure, that will basically degrade the structure or fabric's characteristics very quickly. So, there are two types of testings are there for degradation: natural testing and accelerated weather testings. Natural testing means you keep the clothing outside in outdoor. So, natural outdoor exposure provides authentic degradation profile. So, which will actually happen to the in a textile material, but the problem here is that it requires long duration, months to years. So, that type of testing, weathering, natural weathering is not done normally. So, for that if we want quick results, so accelerated testing is there. So, where the proper UV ray and proper temperature, proper humidity are kept. So, this will actually give the acceleration factors. So, careful validation of acceleration factors and failure mechanisms are important. So, though real world situation is very important, natural weathering is very important, and it gives a real world performance, but for by doing accelerated weathering test, we can create one acceleration factor to predict. Now, let us try to understand the UV ray. What are the different types of UV ray? What are their wavelengths? So, UVA is basically it is a long wavelength 315 to 400 long wavelength, and the UV radiation makes up to 95% of UV reaching the earth's surface. The long wavelength majority almost 100% is reaching, so it penetrates through the ozone layer. So, it is a long wavelength, maximum it is reaching to the earth's surface, and UVB which is medium wavelength 218 to 315 in that range. So, medium wavelength is partially absorbed by ozone layer, and UVC which is short wavelength with a high energy. So, that is why here short wavelength radiation, it is completely blocked by the atmospheric that is mainly through ozone layer. So, this up to 280 it is not reaching into the earth. So, we are not basically worried about the UVC short wavelength. So, the waves which are reaching are UVA majority and almost 95%, and remaining 5% is UVB. So, for all the testing, all the UPF, we consider UVB and UVA, that is from 280 nanometer to 400 nanometer. So, 280 nanometer to 400 nanometer, which includes the UVB and UVA. That range we always test. In the UPF rating, we consider only this within the this range of UV. 100 to 200 nanometer we do not consider, because it does not reach to our to the earth. So, understanding these three distinct UV is essential for assessing the exposure risk and selecting appropriate protection method in the laboratory and in the field environment. So, this proper understanding of these waves are important. So, as we have seen, the UVA is reaching, UVA and UVB are reaching to the earth. So, we must be concerned about the UVA and UVB more than UVC. UVC is basically above the ozone layer, that is there it is very harmful. Now, you can see the UVA characteristics. So, its properties that you can see, the UVA radiation penetrates deep into the skin, reaching the dermis layer. So, it is reaching deep into the skin. So, if in the skin, if you see at the top layer is the epidermis, and then it is a dermis. So, it penetrates deep into the skin, which affects in the dermis layer. So, as we have mentioned, it accounts for 95% radiation reaching to the earth. So, as it is a long wavelength, it penetrates through the ozone layer easily. So, it 95% is in the earth's surface, it is reaching, maintains relatively constant intensity throughout the day. So, it is throughout the day the intensity it remains constant. It penetrates glass and clouds cover effectively, causes long term skin damage, okay, and premature aging. So, these are the effects. So, premature aging will be there and long term skin damage take place. It contributes tanning and pigmentation. So, the aging, premature aging, tanning and pigmentation are basically due to all the 95% this our UV ray and less intense, but more abundant than UVB. So, UVB intensity will be more because of the lower wavelength. Okay. It is a long wavelength. So, intensity is less, but it is a quantity which is present, it is a 95%, whereas UVB is typically around 5%. Now, let us see the UVB and UVC characteristics. So, UVB radiation, it is partially absorbed by the ozone layer, and out of that only 5% is reaching to the earth surface. So, it is partially absorbed, and in UVA it is 95% is reaching, only 5% is absorbed, and it is high energy radiation. So, it is a low wavelength, lower than the UVA, but energy radiation is higher than UVA, is primarily causing the sunburn and plays crucial role in vitamin D synthesis. That is important. It is harmful, but at the same time it actually synthesizes vitamin D in our body. See, its intensity varies by time of the day and season. At the season, at different season it intensity varies, but in case of UVA it remains same throughout the day. Even with the change in season, UVA intensity always typically remains same. And here thing is that it directly damages DNA in the skin cell. So, that is affected. So, and it is mainly contributing the skin cancer risk. So, UVB is basically DNA damage is there and skin cancer risk is there. So, we need proper textile for this protection, and blocked by glass, not by water. So, earlier we have seen the UVA, it penetrates through glass, but here UVB, which is not that harmful, the UVA which is not that harmful, it can penetrate through the glass, but UVB is harmful, which is actually blocked by glass, but water, through water it penetrates. Now, the most dangerous is the UVC radiation. So, it is the most dangerous form of UV radiation, but the advantage, the good thing is that it is absorbed 100% by the ozone layer. So, from the sun when it is coming. So, this UVA is completely absorbed by ozone layer, and here it is a 0, that is so that is a basic good thing. So, here it is very dangerous, but it is not reaching to our human body, but the problem is that where there is a ozone hole due to the in the atmosphere, there may be some ozone holes there due to the climate change. So, this if in case of ozone layer there it penetrates through that. So, there the chances the exposure is very dangerous. So, it is completely absorbed by the earth's ozone layer and atmosphere under normal condition. Okay. It is only encountered in artificial source like germicidal lamp. So, in those cases we should be away from this type of lamp where the germicidal activities are taking place. So, there it is UVC is created. So, it is extremely hazardous to all living tissues. That is why the germ, to remove the germ we use the UVC to kill this all this germ. So, here it is extremely hazardous to living tissues. So, if we want to remove germ, so we use the UVC there, but it does not but there if any one is working near this artificial source, okay, their proper protection has to be there, extremely hazardous. This is used for laboratory sterilization and requires, if someone works in near the sterilization, it requires special safety protocols, that is very important. So, special safety protocols are required there. So, UVC we are not worried about in normal case, but for special condition. So, proper protective clothing has to be there. So, it can cause severe eye and skin damages. So, proper protection has to be there. Now, let us try to understand the how the atmosphere absorbs the UV radiation. So, these are the different layers in the atmosphere. So, Earth's atmosphere acts as protective shield against harmful UV radiation like UVC. The stratospheric ozone which is present, the ozone layer absorbs most of the UVB, at least 95% UVB it absorbs, and UVC. So, basically as the wavelength reduces, the radiation becomes more damaging. Okay. So, this is the lowest wavelength. So, it is more damaging, and UVB is the moderate wavelength. So, it is also it affects the human body. So, this atmospheric ozone layer absorbs most of the 95% of the UVB and almost 100% UVC radiation, while oxygen and water vapor provides additional filtering. So, here in the atmospheric layer, so when oxygen and waters are present, their water vapor like in the form of cloud or maybe oxygen, that also enhance the this UV that it will block the UV ray to come, it filters the UV. So, this without this atmospheric protection, if the layers, can we imagine a situation the layers are not there. So, directly the UVA, UVB, UVC ray and will come. UVB 100% will come, then life could not exist in the earth surface. So, this is the atmospheric shield. So, and we are protecting ourselves whatever the low intensity or UVA is coming, that for that we are worried about protecting ourselves through the protective clothing. But imagine if this atmospheric protection was not there, then the life we cannot actually exist in the earth surface. So, ozone layer absorption, let us see, it blocks 97 to 99% of UVB, okay, and all UVC radiation. So, typically 95% we assume that, but 97 to 99% UVB it absorbs. Molecular oxygen filtering. So, we have discussed that the oxygen present in that in the atmosphere, so absorbs UV radiation below 240 wavelength. So, below 240 wavelength it absorbs, that means it will help the ozone layer, whatever it is a lower wavelength the layer UV ray is coming. So, the oxygen present, the what oxygen molecule present, that also it filters, and water vapor or aerosol, whatever particles are there, that this scattered on and absorb the remaining UV radiation. So, this is this actually helps the water vapor, aerosol, oxygen, ozone layer helps in protecting us from harmful UV radiations. So, let us see what are the different factors which affect the UV transmission. Time of the day. So, UV intensity peaks between 10 am to 4 pm, that we have discussed, where when sun is at height, that UV exposure will be more. During these hours, up to 60% daily UV exposures are occurring. So, within this 6 hours time, so 60% of UV exposure is coming, and remaining the 18 hours. So, we get the typically rest 40%. Remaining time of the day, basically not 18 hours, remaining whatever day timing is there, 40% is there, and altitude. So, with the increase in height from the say sea level, so UV exposure increases. So, it approximately 10 to 12% of UV exposure increases per 1000 meter height per kilometer. So, if every 1 kilometer elevation, the UV exposure increases by 10 to 12%. So, we have to protect ourselves at that accordingly, if we are going at the high altitude. So, this is mainly due to thinner atmosphere which reduce the filtering. So, oxygen level is not there, there you will find that there is a moisture vapor is not that high there at high altitude, and also the particles are not there, which helps in absorbing or scattering the UV ray. And latitude, UV intensity increases, that we have discussed that earlier, increase closer to the equator. At equator the UV intensity is maximum, where the sun rays strike more directly throughout the year. In the polar zone it is just reversed. At the different season the UV transmission or it changes. So, UPF UV index for a particular place, it also gets changed with the season. Summer months bring stronger UV radiation due to Earth's tilting and sun's angle. So, it gives stronger UV. UV levels can be 3 to 5 times higher, that UV index. So, can be 3 to 5 times higher in summer than winter. So, at summer UV, so we have to create clothing. So, different types of clothing in the summer. So, our protection levels UPF value should be higher than the winter. So, cloud cover, in the when it is a cloud is cover. So, it actually reduces the UV radiation, but it will definitely it will come penetrate through cloud. Thin cloud may block 20% of UV, whereas thick coverage it reduces by 90%. So, that depending on the type cloud intensity, the UV transmission takes. So, we should take care of all these aspects. So, another is air pollution. So, air pollution, that particles are there. So, in urban pollution and particulates can absorb and scatter UV ray, reducing the ground level exposure by 10 to 50%. At very high pollution level, the UV exposure is reduced. So, depending on all these issues, we should actually develop our clothing accordingly. Suppose in a daytime around 12 p.m. at the noon. So, we must wear a clothing with high UPF value. If we go to the high altitude, we must select a clothing with high altitude. If we go to the equator, so we must have higher UPF value. So, in the summer we need higher UPF value. If there is any no cloud, so we need higher UPF value. If there is no pollution, we need higher UPF value. So, depending on the environmental factors, we can select the clothing which is based on the UV transmission. Now, the scattering and surface reflection effects. Now, atmospheric scattering is there. UV radiation does not travel in straight line, it gets scattered by the air molecules in all direction, creating diffused sky radiation. This means you can receive UV exposure when you are in shade. So, suppose a person is in the shade and he is thinking he is protected. So, this is the sun ray is coming directly, but due to the particles present, multiple scattering is taking place and from there you can get it. So, multiple scattering, it will you are exposed to the UV ray so these are different types of particles are there, and surface reflection. As we have discussed, different types of surface, snow or ice, it reflects the UV ray, different surface reflects varying amount of UV radiation and which significantly increases the total exposure. And we must understand the reflection level. So, fresh snow, highest reflection, it is becoming white. So, this is 80% reflection, it can get reflected. Dry beach sand, so substantial reflection, 20% of the incident will get reflected. And water surface like seawater, any surface that reflects 10%, so moderate reflection. So, when we are in this type of environment, so we can protect ourselves accordingly. And grass and soil condition, they are minimal reflection. So, if we use, there is a different types of grass, is the grass does not reflects too much. So, UV exposure measurement units, what are the exposure measurements? UV index, this detail with the example we will discuss subsequently in later stage. UV index is actually, it is not the related to the fabrics or any protective garments or sunscreen, it is a environmental UV. So, it is a scale, it is a from 0 to 11 scale indicating daily UV radiation intensity at a particular location. That is the UV index is basically it is in a environmental condition it is there. So, values 3 to 5 indicates the moderate risk at that place. So, 3 to 5 UV index in a place in an environment, it means it is a moderate risk is there. 6 to 7 high risk, 8 to 10 is very high risk, and 11 and above it is extremely high risk and which requires maximum protection. So, we must know in a place what is the UV index of that place. Okay. And another way is that UV exposure we can get is a MED, minimal erythemal dose. So, minimal erythemal dose is basically its amount of UV radiation required to produce minimal skin readiness in 24 hours of exposure, that is called MED. So, 1 MED equals to approximately 200 to 300 joule per square meter for fair skin and varying by skin type and wavelength. So, this is MED is also measured, it is also UV exposure measurement unit, and also irradiance, this is another unit which is it is a power watt per square meter, okay. That is a power of UV radiation that is measured, like UVC has got high power, UVA has got lower power. So, that power irradiance we measure in watt per square meter. So, power of UV radiation in watt per unit area. okay, measured in watts per square meter. This technical measurement is used for in the laboratory setting and for the precise UV dosimeter calculation. So, we need how much UV has to be dosed. So, that for that we need to calculate the, we need to know the power, how much power of the UV has to be dosed. For that application we need this unit, irradiance unit. Okay. So, we will stop here and we will continue with this UV protective textiles. We will try to understand more about the UV exposure and their effect on the human body, and how we can develop our clothing, what are the different factors which in the clothing which controls the UV radiation. So, till then, thank you.